Good morning, everyone. Thank you for joining EAC's webinar this morning. I'm just going to give it another minute and let some more people trickle in here. Todd, you can go to the next slide if you want. This is Addison Tyne. I am the marketing specialist here at EAC. We will be recording the session today, so pending any technical difficulties, everyone will receive a replay of the webinar. Following the session today, a short survey will appear, so please stick around and answer these questions for us after the webinar. As we wait for everyone to join this morning, I will just go ahead and start with a short introduction of EAC before handing it off to our technical account manager, Todd Libanow. Then you can go to the next slide, Todd. At EAC, our mission is to transform the way companies design, manufacture, connect to, and service their products. We are located all over the US, and our headquarters are currently established in Minneapolis. We are more than just a value-added reseller for PTC, though. For over 20 years, we have helped companies innovate their product development processes. With experts in over 22 different areas of product development, we help organizations create better products, rethink what may seem impossible, and ultimately achieve results that make a lasting impact on the world as we know it today. Beyond helping organizations connect to the information they need, we also work with companies to connect their enterprises, as well as focus on specific focal points which produce bits and pieces of their operational value. We also assist with design and engineering projects, host educational webinars, and PTC certified training courses. All in all, we want you to know that EAC is a company to get all the technology at the forefront of your business to help make your team successful. Our niche is helping you figure out where to start. Our specialty is helping you build on what you already have. With that, it looks like a few more people have joined us now. So I will go ahead and pass things over to Todd, so we can get a better understanding of what's so great about simulation anyway.
Addison, I apologize. I don't know why that slide wanted to go to this one, but at any rate, it was pretty adamant about showing this one. So that's me. Let's go ahead and get started. If we click on this guy, it should advance to the next slide. Wanted to talk about this first. What is the digital thread? So part of what we're talking about today is a number of different tools that are available to designers and engineers in the design process. But instead of just kind of focusing on point solutions, we want to step back for a minute and think about a bigger picture and think about this digital thread. How does this actually tie together the rest of into the rest of the product development process? So things we're focusing on today are the design tools and simulation and things like that. But then we want to be able to make sure that we share that information upstream and downstream so that everybody else that in the organization, as well as suppliers and customers, are all taking advantage of that information. So the thought process here is that we're working with a single source of information with the design models, and then sharing that information in the right place at the right time so people can make the proper decisions for design and business. So today's discussion is really going to be around the simulation and analysis solutions that we have available to us inside Creo Parametric. Again, the right tools at the right time working together seamlessly. Really two main threads or thought processes there. We have simulation-driven design, where we're sort of on the earlier stages of the design process, and we're doing what-if scenarios, and we're trying different options and looking at different candidates for design and things like that. And the second branch there would be more traditional analysis, where we're a little bit more finalized in our design, and we're needing more high fidelity analysis, simulations and things like that, so we can sort of validate the design and make sure that we're getting exactly what we want. So it really breaks down into these two different tool sets. On the left-hand side, we talk about the simulation-driven design tools, and there's a list of items there, and we'll talk about each of those individually. And then the more traditional design or analysis tools on the right-hand side. So first off, if we think about the early analysis type tools, we think about Simulation Live, Generative Design, and the other items that are on the list. So we're thinking about how do we look at our model, how do we actually make changes to it, what kind of changes are appropriate, am I making the right kind of changes, is it manufacturable, and we want to do some simulations and maybe minimize the amount of physical prototypes that we're going to make through the use of these simulation tools and make decisions based off of that. So the first tool that we're thinking about here is Simulation Live. Creo Simulation Live is the real full name for that. And the slide talks about, well, why do we need it, right? So what it is it's a tool that provides real-time, virtually instantaneous results about the design and the decisions that we make about thermal studies, structural studies, vibrational, and now in Creo 7, flow type studies. And this is powered by Ansys, right? So it's Ansys functionality that's integrated inside Creo Parametric that lets me do those 4 different types of studies. Again, it's structural, thermal, vibrational, and flow type analysis. And so the thought process here is that I'm using Creo Simulate Live to help me sort of make general design decisions. Am I making the right features? Am I adding the right geometry? And is it trending in the way that I want? So it's more of a directional tool to help me make design decisions about, do I add that rib? Do I what's the right number of fins for a heat sink? Is the general flow over the model or through the piping system, is that doing what I expect? Am I getting the type of behavior characteristics that I want? So, and again, it's pretty much real-time information about how the model is going to behave based on the design decisions that you make. The next slide talks about generative design. What do we need? What is it, and why do we need it? So it's an additional extension that gives you access to making design models based on the load case. So instead of just starting off with a chunk of steel or aluminum or something like that and applying design features to it, we might cut away different areas of the model. We can actually have the model respond to different load cases and different scenarios, and have it figure out what's the right amount of material to have in the model, and where does it need to be to support that load case. So it's an ability to make some real radical design changes, breakthrough innovations and things like that allow me to design and develop products, give me higher quality designs, and really changing the thought process behind this. So this can also be leveraged in 3D printing, right? So it might be tough to manufacture that part, but now with the advent of 3D printing, we can actually manufacture these parts and include this high performance design into our models or into our production and get the higher performing models. And it's all really based on the load case and the design criteria, the goal. What am I trying to do with this model, and what performance characteristics do I need it to have? And then the generative design can help you determine what does that part need to look like in order to carry the load successfully and perform the way that you need to, while you're minimizing mass and making it as an efficient, effective part as possible. And of course, on these slides, we'll have some examples of how different companies have used the different functionality. In this case, we're talking about Volvo, that's using generative design to transform how they make parts and go through a real aggressive weight reduction program. Kinematic Analysis. So you might think of this as part of your base suite of Creo Parametric. It's the mechanism design extension. So everybody should have access to that in a modern Creo license. And this is a tool set that lets you put your assemblies together very much like you would in the shop, right? Using things like connections, say like a ball joint or a pin joint or a slider joint, that lets you run the model through kinematic studies. You can do range of motion, fit and interference type studies, and sort of look at the model like you would put it together in the shop, and make sure that you don't have any issues with that mechanism before you actually start to put it together and make parts and do those types of things. So again, everybody should have access to that kinematic study tool set with the mechanism design extension. Next, we would talk about mold analysis and why do we need it. Well, so if you're designing injection molded plastic parts, one of the things you might be interested in is that part actually manufacturable based on the design that I currently have? And so a lot of times, people will design the part and then they'll give that to their supplier, and then the supplier will have to do some work on that to figure out, well, what's the gate location? How many gates do I need? Is that even manufacturable? Will I get a short shot? Will I get the quality of the part that I need? Will I have sink marks? Will I have air traps and weld lines? And if they, I'll probably have those things, but where will they be located in the model? And is that okay for me to have those at those locations, or do I need to consider maybe doing design changes or those types of things to help me get the quality of the part that I want And again, the idea is to incorporate that thought process into the design early on in the process, so I don't have to, try and figure out what happens after I've cut steel for the tool. I got to change a gate location or make some other modification to get the kind of part that I need. It's much more expensive to do that in steel than it is in the simulation tool. So again, we're just highlighting the different tools that we have and how you can use those and incorporate those into your design process. Another tool that we have is the clearance and creepage analysis. So in this case, we use this tool to identify electrical clearance and creepage design flaws. So what you can do here is validate and optimize for electrical product safety to improve the quality and protect the company, right? So the idea here is to take a look at the model as it's designed and figure out, well, do I have a proper clearance between different electrical components? Do I need to put in some sort of insulating material or different geometry in the model to make sure that I don't have any undesired electrical arcing or something like that might happen if I don't take care of that. So again, it's a different set of tools that lets me look at my overall assembly from the electrical standpoint and determine if I might need to make some changes for maybe locating fibers in a different location or adding some other geometry to protect the assembly. Tolerance analysis. Tool set here is to take a look at our model and think about it from the manufacturing standpoint for manufacturability. So we have tolerance stack up and gap analysis tools that let me identify and modify critical tolerances to give me the quality and manufacturability targets, and I can attain them. So we can look at this from the standpoint of the features in the model and say, well, if I manufacture this to maximum or minimum material conditions, am I going to be able to assemble this? And it helps me understand which dimensions are critical to make sure that I hold the tolerance on, and which ones are are a little bit less significant, and actually make that part or make that assembly more manufacturable and help me understand the things that I can safely change without having any downstream issues with the model. So thinking in terms of Six Sigma and tolerance analysis, it's really a drive for a lot of companies to improve their product design, and this is a tool that you can use to help you figure out which characteristics are important for your model. Human factors. So you might see this in the ribbon in your Creo assemblies. This allows you to put a mannequin into your assembly, and that's kind of fun initially, and you say, well, yeah, that's kind of interesting, but why do I care? Why do I need that? Well, we can do studies with that, right? So we can look at how people are going to actually interact with your model or your design, right? Can they actually reach the control panel? Can they actually safely hold that position for a certain period of time? So you can do different types of studies for ergonomics and range of motion, field of view, and things like that. Can the 5th percentile woman actually reach that control and move that lever, or do I need to move that to a different location so that's safely reached or activated? So again, it's kind of fun to do that, but it's also important from the ergonomics and human interaction with your design. Creo Product Insight. So this is a functionality that lets you interact with your design and get real-time live information back from the field. So what we're showing here in this case is we've got different sensors that we've included inside of our Creo design, and we can connect those up through ThingWorx and get real-time information back in the performance of, in this case, this loader arm or the bucket. So I can get sensor information from the field, and I can then use that for simulation or different design studies. So instead of making assumptions based on what I think that load case is going to be, I can get real-time data back from the field, from the actual product as it's operating and doing its thing, and show what that's going to look like in Creo dynamically. So again, it's Creo Insight that lets me connect to my product in the field and show what that's going to do inside the Creo design environment. Behavioral modeling. So in this case, what we're talking about here is the a lot of times what happens is, as a design engineer, I remember, I would oftentimes make changes to the model and try and figure out, well, if I make this dimensional change, if I move this feature to that location, what does that do to the model? How does that change my design performance or design envelope? And a lot of times I felt like I was throwing darts at a dartboard, right? So you make a change and then you do some other test or simulation, and then you say, well, it kind of did what I wanted, but maybe not really. And then I've got other dimensions or parameters I can change to the model, and I start, moving things around. It's oftentimes really hard to understand what the changes that I'm making in the model actually do to the performance of the model. Well, with behavioral modeling, we can sort of, short circuit that process and say, you know what, I've got a certain goal. I want to maybe minimize the mass, or take a surface area and make sure I maximize that, or I've got some other design goal based on geometry, and I want to drive that to a certain state. I want to move center of gravity to the axis of rotation on a shaft, or if I'm going to pick something up, I need to know where the CG is, and I need to maybe move around the lifting lugs so I actually can better control that mass or that object that I'm picking up based on where the CG is. So obviously I can make changes to that quickly and easily inside Creo, but what impact does that have when I do that? Right? So behavioral modeling lets me sort of target that. I can say I've got this goal that I want to achieve, and then I can assign other different objectives, right? So maybe minimize the mass or something like that, or minimize the distance between a CG and an axis of rotation. Then I can use different design studies to help me figure out, well, which parameters or dimensions are really significant and which ones do I ignore, right? And then I can sort of use the results from that to do an optimization or a feasibility study that lets me drive that to that goal. So instead of me sitting at my desk throwing darts at a dartboard, I can use behavioral modeling to get a better understanding of what the model's actually doing based on the dimensional changes or parameter changes I'm making. So again, behavioral modeling is a real nice tool to help me do real true engineering instead of just kind of taking a swing at things and making dimensional changes. So that's sort of the summary of the things on the left-hand side, the simulation-driven design. Then on the right-hand side, we talk about the more traditional analysis tools, right? So won't read the list, we'll just jump right to the slides. But the idea here is that we're creating higher-end analyses and looking at the tools that we'll be using to do that. So the first one is mechanism dynamics, right? And this is really the second half of the mechanism functionality that's inside Creo. MDX, or mechanism design extension, everybody has that, and mechanism dynamics is an additional optional module that lets you do dynamic studies. So this will help you understand how forces and torques that you apply to the system result in the motion of the system. So you can do dynamic studies. You can include things like friction and dampers and springs and gears and belts, gravity and those types of things. And you can have it calculate reactions and at the locations of the model, forces, velocity, acceleration, things like that. And then those results from your dynamic study can be brought into Creo Simulate or Creo Simulate Live, and then used to do further studies from there. But this is really sort of the one-two punch of mechanisms inside Creo. Is you can set up the model with kinematics, and then you can do dynamic studies on that to help you sort of drive the design and do more detailed studies on it. Then we talk about Creo Simulation, right? So there's several different tools that have the name, the word simulation in the name. So let's talk about them and kind of differentiate between what they are. So Creo Simulation is a tool that you use for structural, thermal, and vibrational type analyses. You can do things like sensitivity and optimization studies in there as well. This is probably used a little bit later in the design process. So you might use Creo Simulate Live, which we'll talk about in a minute. We'll talk about the tools of the Creo Simulate, so you can do more detailed, high resolution studies, sensitivities, which parameters are important, which ones can I ignore, optimizations. So I want to minimize the mass, but then keep the stress below a certain value, and then try and drive toward an optimum design using that tool. So again, it's very similar to behavioral modeling, except the focus here is, as I mentioned, on structural, thermal, and vibrational type results, whereas behavioral modeling is more geometry based. So think in terms of the measurements that you create inside Creo, like areas, volumes, distances, other mass properties, things like that. Creo Simulate is really focused on more of a traditional structure, thermal, or vibrational type analysis. Then advanced simulation, that takes and builds upon the Creo Simulate and gives you some additional capabilities for nonlinear materials, nonlinear contact, large deformation, pre-stress static and modal analyses, transient structural and thermal analyses. Things like composites and those types of things are also included in Creo Simulate or the advanced version of that. So that's the different tools for as far as Creo Simulate. Additionally, there's Fatigue Advisor. So what this does is extends the capabilities of Creo Simulate, and this is a tool that is used to predict the life of the metal structures that are often prone to fatigue with cyclic loading type conditions. A typical example everybody thinks about is bending a paperclip a bunch of times. You can do that for a while, but at some point that's going to break down, right? And that's a fatigue situation. And so you'd use Fatigue Advisor to help you figure out what is the what might you do to your design to change or minimize the impact of that cyclic loading on your model, so you can have it perform the number of life cycles that you need it to before it should actually fail. So again, the idea is I want to build prototypes here digitally before I actually go out to the shop and into the field and create models or prototypes there. Next, we would talk about flow analysis. So this is a tool that's available through PTC and their partner Cimerix. So this is an integrated tool that's inside Creo Simulate. And what we're looking at here is the ability to do CFD type studies used to identify design flaws early in the process. Different types of flow studies, both internal and external, are available for CFD type studies. People have asked for this kind of functionality from PTC for a long time, and they've established a partnership with Cimerix to give us access to that kind of capabilities now integrated inside of Creo Parametric. Next, we would talk about Ansys Simulation. PTC is continuing to deepen their partnership with Ansys in the simulation tools, and this is building upon that partnership. So we're talking about Ansys Workbench functionality running now inside Creo, specifically Creo 7. So this is sort of parallel functionality to Creo Simulate, but it's actually using the Ansys functionality as shown here. It's integrated, and now that Creo 7.0.2.0 is available, that we have access to that functionality. The analog tool for that is Creo Simulate Live, right? And so there's two different levels of Ansys functionalities that are now available inside Creo Parametric. The Creo Simulate Live is, like I mentioned before, it's that more predictive tool used early on in the design process, helping me understand, am I making good design decisions? Am I, adding geometry, moving things around? And when I want a more detailed result from that, I might look at either Creo Simulate or the Creo Ansys solution for a more detailed, complete result. So that's an overview of all the different modules and items that are available. Sorry, it ends up being more of a PowerPoint presentation. We can certainly look at things live if people have certain questions about any of the specific areas of functionality. I don't know, Addison, if we have any questions at this point that have shown up in the queue.
I don't see any questions right now.
Okay. All right. Well, that largely covers what I had. I have some appendices type information that I can cover here briefly. This is kind of talking about maybe some future information as far as what the differences are between Creo Simulate and the Creo Ansys solution, and what's covered and what's coming, right? We can talk about that, and then some additional, this is future information there that's coming as far as Creo 9, but that's a little ways over the horizon. And then product capabilities as far as, again, 9 and 10. So it's been necessarily a lot of time on that. If people have questions, we can certainly dive into that as needed. That's what I have for presentation. If people wanted to look at some of the additional functionality or specific functionality, we can. I know that we have done several webinars that cover a lot of these topics. So that might be something that we can reference too if you have specific questions. I know we've done them on Creo Simulate Live and behavioral modeling in Creo Simulate. I know I did one on the flow analysis too, but if there's questions on that, happy to entertain those now.
Right, and I don't see any questions popping up so far. I just want to thank everyone so much for joining today's webinar. To wrap things up this morning, another reminder, there will be a short survey that will appear once we end here. If you have a couple more minutes to spare, we'd really appreciate it if you could stick around and answer those questions for us. Before we wrap things up this morning, though, I do want to let you all know that you can explore even more from your software investment with simulation-related special offers of up to 33% off until December 31st. To learn more specifically how simulation can help your team and what simulation solutions best fit your needs, we'd absolutely love to start the conversation with you. So feel free to reach out to either myself or Todd with the contact information I provided on the slide here. And we'll be sure to get you pointed in the right direction. Thanks again, everyone, and I hope you have a great rest of your day.